Hello, my name is Christopher Sjolund, and this is my poster on investigation and development of 2D and 3D EDS towards the creation of a hybrid dust mitigation brush. My co-authors on this project are Dr. Micah Schaible, Mary Judson, Emily Ryan, Dr. Maisha Shofner, Dr. Thomas Orlando, and Dr. Julie Linsey. All members involved in this poster are from the Georgia Institute of Technology. With NASA's plans to return to the moon with the Artemis missions, robust dust mitigation solutions will be necessary. This work is a part of an effort to create a volume-affecting form of electrodynamic dust shielding, or EDS, that astronauts can use to clean their spacesuits and other surfaces. To accomplish this, effort has been focused on replicating 2D EDS, or EDS that affects a space, using reduced graphene oxide. This material, which is also referred to as RGO, is a novel polymer composite developed by the SSERVI Reveals team. The system has been combined with other dust mitigation techniques, including UV radiation to photoelectrically charge the dust grains, and vibration to cause tribocharging. Experiments involved the use of HDPE samples with interdigitated electrodes of RGO laminated into the surface. All experiments were conducted in vacuum between 10 to the -6 and 10 to the -8 torr. Further details of experimental conditions can be found in the methods section on the poster. Two surface finish conditions of the sample were considered, rough and smooth. Figure 3 shows the mean cleanliness achieved from the two conditions using only EDS. Both were able to achieve greater than 90% cleanliness, but the rough condition was able to do so at 1000 volts peak to peak, while the smooth condition required 2000 volts. Higher voltages could achieve near complete cleanliness, but doing so causes breakdown of the RGO. To investigate the effect of combined EDS and UV radiation, an excimer UV lamp was used. The smooth and rough conditions EDS samples were tested under the same conditions with 5-second pulsed UV exposure. Figure 4 shows the cleanliness achieved from all experiments. Note that the UV exposure halved the required voltage necessary to achieve high levels of cleanliness. An additional condition, with LDPE laminated on top of the RGO sample, was also investigated as a coating layer will be required for practical implementations of EDS. While we have yet to construct a new form of 3D EDS, or EDS that affects volume, the findings from the 2D EDS experiment will significantly aid in the development process. Future work will also need to consider EDS that uses 3-phase signals, as the experiments discussed here used 2-phase signals. Further investigation into different coating materials will also be completed. This work was directly supported by the NASA Solar System Exploration Research Virtual Institute, or SSERVI, under a cooperative agreement with the Reveals group. It was also a part of NASA's 2021 Big Idea Challenge with a Shoot for the Moon from Georgia Institute of Technology.